So we're going to take a look at the law of signs, and we are going to look at the ambiguous case that comes with the law of signs. The ambiguous case is basically saying, well, you can solve a triangle using the law of signs, and what may happen is you could perhaps produce one triangle, maybe two triangles, or maybe no triangles. So you're probably thinking, well, how does that happen? Okay, so law of signs. If we go back, law of signs, we could use, if I'm thinking like days of geometry, if I had a triangle that was the angle, side situation, where two angles and a side had given information, law of signs works. Law of signs also works on the super fun side-side angle case, which we know in geometry will not prove triangles congruent. Okay, so triangles cannot be congruent using this. And I'll try and show you perhaps why they can't be congruent, but then knowing that why they can't be congruent would also show you why you could perhaps have a two triangle situation with this case. Okay, so if I'm looking at, let's say for instance, this triangle ABC, the things that have markings on them are going to be our fixed information. Angle A is fixed, meaning it's an angle measure, it's not going to change. Side AB is fixed, it's a side length that won't change. Side BC is fixed, that's a side length that won't change. So these are given fixed pieces of information. Things that could change. Angle B could change, angle C could change, side AC could change. Okay, so with that being said, I'm going to go back to our days of geometry with my compass and straight edge, and I'm going to take my compass, sharp point at B, drawing point at C, and I'm going to create a circle. And the reason I'm doing this is because what you're going to notice, I know it's not a full circle, but you're going to notice that side BC is a radius of that circle. If I were to connect that circle all the way around, I could see that that's a radius. And what you know about radii of a circle is all radii are congruent. So if B was the center of the circle, which it was, because that's where our sharp point of the compass was, and this point is on the edge of the circle, and I were to connect them using a straight edge, I could show you that the length from B to C is the same exact length as B to, I'll call this C prime. So these two things have to be the same because they're both radii of the circle. So if that's the same length, now notice what you've just produced, two different triangles with the same given information, that side-side angle case. So you have that original triangle, triangle ABC, right, this little guy here. And then what we also have is triangle A prime. I shouldn't say A prime, it should be A to B to C prime. So these two triangles, notice what they have. They have the same information. They have the angle that stays the same in both the small little triangle and the big one. This side stays the same, right? That's both in the small triangle and in the big one. And then in the small triangle, we have side BC. In the big triangle, I have side BC prime, but they're the same length because they're both radii of the circle. So this is a situation where you have two different triangles. Okay, so you could use law of signs, but you may actually have two different situations. One thing you want to be careful with is when you're doing the law of signs, different ways that we can solve it. I like to use the isosceles triangle method where, since these two are both equal side lengths, that creates this inner triangle that's an isosceles triangle. So I know then this angle here and this angle here must be the same size. We're going to get to that in a second, but just keep that in mind. That's an isosceles triangle method. There's other methods out there. That one's probably more so my favorite because to me, I think it visually makes sense. But that is why angle side can't prove triangles congruent, but why using the law of signs you could get two different triangles. Now the case when you get zero triangles, what basically happens is the side is too short to actually connect. So you would maybe have a triangle that would look like this. And the side doesn't connect. You have a gap here. And what happens is when you try and do something with your law of sines, you're going to get an error message on your calculator. So you try and take and either find an angle or find a side length, and when you plug it in on your calculator, it says error. That means then you have 0 possible triangles that can be created. Okay, we'll do a little bit more on this, but that's just kind of an intro into the ambiguous case.